So we talked about chemical equilibrium today, and I want to, for just a moment, talk to you about how to set up the equation for law of mass action and talk about the equilibrium constant K. Now, it is very unlikely that you would be asked to solve for K on the exam, but you might need to be able to write the law of mass action, which I will abbreviate LOMA for short. So if you look at this chemical reaction, and let's assume it's at equilibrium, I'll go ahead and put the equilibrium sign there. So here we have a balanced chemical reaction where the capital letters A and B are the reactants, C and D are the products, and then the lowercase letters H, I, J, and K represent the coefficients from the balanced chemical equation. When you write the law of mass action, it's a ratio, and you will write the ratio, take your concentration of your products. So we would put square brackets mean concentration in molarity back from the solutions chapter. So we'd say concentration of C raised to the J power, whatever the J would be, times the concentration of D raised to the K power, whatever K might be, divided by concentration of A raised to the H power times concentration of B raised to the I power. Typically, we would plug in concentration values if we knew them, and then do the math with the superscripts. And when you do that, you will solve and get a K value, which is K is your equilibrium constant, and that gives you an idea of how far to the left or right your equilibrium position is. So one thing you want to remember here is you'd never include solids or liquids. So you would look at your reactants and products. If any of them were solids or liquids, you would ignore them and you would not include them in your law of mass action. In the law of mass action, LOMA. So let's look at this for a real chemical equation. So if you take, for example, this reaction, again, my program does not allow me to write the equilibrium sign, so I'm going to write these in here for the examples. Okay, these represent chemical equilibriums. So if we're going to write just the law of mass action, not calculate it, but just set it up, you would write K equals, look to your products, and you would put concentration of carbon monoxide. Now, you want to make sure your equation is balanced. So let's just check that. You have one carbon here and one carbon here. You have one oxygen here, one oxygen here, two hydrogens here, two hydrogens here. So it is balanced. So that will be concentration of CO to the first power, because that's the understood one coefficient here, 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 and here, times the concentration of hydrogen, H2, again, raised to its coefficient power, which is 1. Notice both of these are gases. Now, you would normally then divide that by the reactant concentrations, but if you'll notice here, carbon is a solid and water is a liquid, so you do not include them in the law of mass action because your equilibrium position is not affected by solids or liquids. So that would be your answer there. Now, you can also, since both of these are gases, you could express your law of mass action in terms of pressures instead of concentrations. So just real quickly, if you're going to do the K where pressures are involved, that's what K sub P stands for. You could do the partial pressure of carbon monoxide raised to the first power times the partial pressure of hydrogen raised to the first power. But most often you're going to see it with concentrations. All right, so pause this for just a moment and you try number 2 and then check your answer. I'm going to go ahead and do number 2. So if we're going to do law of mass action here for number 2, you would look, you have both of these are aqueous. So we're going to say K is equal to concentration of the H3O plus ion, which is the hydronium ion, raised to the first power times concentration of the acetate ion, C2H3O2, raised to the first power, divided by, this is aqueous, so we will include it, concentration of acetic acid, HC2H3O2, raised to the first power. Now water is a liquid here, so we will not include it in the law of mass action. So this would be the law of mass action for example 2. Okay? That's it. That's all there is for the law of mass action.